This recording, we're going to look at something called the normal distribution or normal curve. It's also known as the bell curve. Let's start by looking at something you're familiar with, the SAT score. Okay? This is an old SAT that only had verbal and math, two sections. So the best score you could get was a 1600. You can see from the shape of this, the millions of students that took this, each one of those dots or circles represents how many students got a particular grade. So we can see that maybe around 5,000 students got a score of 1400. We can see that most of the students, the mean's probably somewhere in the middle here, around 1,000 or so, maybe slightly above that. The mean, I don't know, about 25,000 students got that. We can see that very few students got out at the extremes, 400 to 1600. Most students got somewhere in the middle. And it turns out, if we have enough data where it's bell-shaped, symmetrical, and only has one peak like this, it's called unimodal, then certain percentages apply that we can use to make predictions about how many data fall within a certain standard deviation of the mean. Let's look at a simple normal curve here. Okay? These are the percentages I was referring to, and they always apply. So if the data is normally distributed, if it says that in the question, then we know that the mean's right in the middle. Half the data would be to the left of that. If you add up 34, 13.5, and 2.5, you get 50%. Well, that makes sense. If you're an average student, your percentile, 50%, you're right in the middle. Half the students are better than you, half the students are less. Do you remember our study of standard deviations from our last lesson? 34% of the students fall between the mean and one standard deviation above the mean, and 34 below. Notice how everything's symmetric. So that means that 68% of the students are within one standard deviation. If I go out to two standard deviations above and below the mean, if I add up 13.5, 34, 34, and 13.5, I get 95% of the students. So that means within two standard deviations, 95% of the data are likely to fall. Okay? It's very rare to be beyond two standard deviations. It's extraordinarily rare to be beyond three standard deviations. Okay? Now, on your regions, we're going to break down those percentages in half. In other words, instead of being 34%, I'm going to split it up into half a standard deviation and one standard deviation above. So let's check this out. Again, still have 50% in the middle. If you were to add up all these percents to the left, you'd get 50. So this is 50% right in the middle, Joe average. Okay, so we mark that. So we put the mean in the middle. Okay, remember the symbol for mean, X bar, like that. It's right in the middle. Okay, and before we had said 34% of the data fall within one standard deviation. If you add up 19.1 and 15, that's pretty close to 34% right in here, right? So this right in here, all this is 34%, 34.1 to be precise to the nearest tenth. Okay? Again, we can see it's very rare to be beyond three standard deviations. Okay? So let's work through the questions that are on your sheet that involve the SAT. So you're going to be given a question of this sort. We need to pick out certain key words here. Okay? The College Board does give you the mean and standard deviation for students taking the SAT. Now in 2011, the mean combined score for the three sections was 1500. The standard deviation was 320. And we know that it's normally distributed. That's the key here. So we know those percentages apply. Okay? So I want you to figure out the value that is one standard deviation above the mean. In other words, take the mean and add on 320, and one standard deviation below the mean. Then play the recording when you've got those numbers figured out. Okay, so hopefully you figured out that 1820 was the score that is one standard deviation above the mean, and 1180 is one standard deviation below the mean. Now let's get into some percentiles. So typically if you get your score report, it might say something like, all right, you got this score, this is your percentile. If I got a 1500, I would be Joe average, right? I'd be right in the middle, and my percentile would be 50%, right? If I did better than everyone else, if I got a perfect score and no one did better than me, my percentile would be 100%. Okay? So I want to figure out the percentile that a student would get if they got a score of 1020. Well, in order to work this out, I think the best course of action is for us to label our diagram. Okay, so on your diagram, let's put 1500 right there under 0, under the mean. We'll label that the mean. Okay. Next, well, this is going by half standard deviation, so we're going to have to take our standard deviation, divide it in half. So if I take 320 and divide by 2, I get 160, right? So we're going to add 160, that'll be half standard deviation above, and I'm going to subtract 160, that would be a half standard deviation below. All right, I get these values, 1660 and 1340. I want to use your head of your calculator to keep adding on 160 and put those numbers on your paper below each one of these standard deviations. Keep adding in this direction, keep subtracting in this direction. Play the recording when you've got those figures. Okay, so hopefully you had those figures calculated. They look like something like this. Of course, you might point out that there is no actual way to get a 540. I think the lowest score you can get is a 600. It's 3 sections. There's no way actually to get a 2460. The highest score would be a 2400. So obviously there's no one that's getting beyond this. 3 standard deviations, somewhere in the middle. All right, now that we've got that figured out, we can start tackling some of these questions. The first question says, what percentile would a student be in if he scored a 1020, excuse me? Well, we have to find 1020 on our chart. So let's hop over here and find 1020. All right? So if I'm interested in what percentile, clearly they're below average, right? So what I need to do is take from here everything below 1020. It's going to be a score that is below average. I need to add up all those percents, the 0.1, the 0.5, the 1.7, and the 4.4. Grab your calculator or your head and add up all those percentages. Okay? Then play the recording when you've got it. Okay, so hopefully you figured out that that all adds up to 6.7, and that makes sense. We thought it would be quite below average. Okay? Do one more with you. 2140. Okay? So I'd like you to find 2140. Clean that part up here. I'd like you to find 2140 this time. Okay, that's way up here. That one is well above average. Okay, 2140 is well above average. Now, if I want the percentile, really what I want is all these scores added up. I want all those numbers right there. Now, I don't know about you, but I'm lazy. I don't like to do a whole lot of work. I think, man, there's got to be a quicker way to do that. So, if you're lazy like me and you want to do that quicker, think of 2 possible ways you could get the answer without adding up all those. Then play the recording when you've thought about it. Okay, so hopefully it occurred to you, well, I could add up all those, or I could simply subtract these from 100. These ones up here to the right are how much below 100 our score of 2140 was. So I could just add up those, subtract from 100. Possibly another way would be to say, hey, if I got a 1500, I was average, so that would be a 50 percentile, right? So I could just add up those numbers and add those to 50. And in any case, I should get the same answer. Okay, so lots of different ways to get to the same answer here. Okay, so we said that was a 6.7. This one is a 97.7%. I want you to figure out the percentile for 1820, for 1340, and then play the recording when you've got those answers. All right, so hopefully you figured out that for 1820, percentile is 81.4%. And for the 1340, the percentile is 30.9%. Okay, last type of question involves number of students. Right? So if I knew that 1,600,000 students took this SAT and the same mean and standard deviation as before, I'm interested in approximately how many of them scored between an 860 and a 1500. Well, because it's normally distributed, those percentages apply. So what I like to look at the 1860 and the 1500. Those are the marks between which I want to find the percent. And I just need to add up all the percents that are in between those two edges. So there's your 1860, there's your 1500. Add up those numbers. And if you do so, I think that you'll find that they add up to about 47.7%, which works out to be a proportion of 0.477. Of course, that doesn't answer the question. The question was, how many of the students fall between those scores? So you're going to multiply the proportion by the total number of students, and that's going to give you the number of students that score between those two numbers. Okay? I'd like you to do something similar for each one of these. Find out the percent between the two scores, make it as a proportion, multiply it by the total, get the total number of students that fall within those two scores. Okay, work this out on your own. Play the recording when you've got your answers. Okay, so hopefully you worked that out. You can check your work. Those are the percents, those are the proportions, multiply it by the total, and those are your number of students that fall between each one of those scores. Thanks for watching.